Okay, in my last video, I showed how you can construct, starting with nothing but circles, uh, the regular pentagon and pentagram, and how you can find within them the golden triangle. So let's look a little bit more closely at this and at the golden triangle. Alright, so the first thing is we are not going to need to see all of this. When I start to hide objects, though, you're going to start to see the construction lines that led up to this, and there are a lot of them. All right, boom, huge. Okay, let's get rid of that, and 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 that. All right, well, that's a little bit more than I wanted to get rid of. Show that one again. Let's get rid of some of these dots at the corner. Well, we don't need to get rid of that one. All right, and boom, yay. So, by cutting down the pentagram within the pentagon, we've got the golden triangle. And some of the lines of the pentagram give us the first couple of divisions of the golden triangle. So, the overall shape, it's an isosceles triangle, which goes from the base of a pentagon to the top corner of the pentagon. And its divisions equal angles. And we're gonna look into this, how we're gonna copy some angles, and we're gonna be able to make a little spiral within this, very much like we did within the golden rectangle. First couple of divisions come from the legs and the arms of the star, the pentagram. All right. So I guess let's go straight into copying angles. All right. The angle you want to copy, first you put a circle from it. And then you're going to take your intersection points where the circle intersects those other sides of the angle. Okay, and you just want, you need one more circle. Now, if you study Euclid, he actually goes into constructing triangles from the circles, but it's the distances that are important. You want an equal distance along both lines, which, as you see, are the radiuses, radii of the circle from its center. So this is the center of this circle, and this is a radius, this is a radius. Oh my goodness. This is a radius, and this blue one is a radius. So they're all equally distant from that point. Okay, the whole circle, the whole circumference, the line itself, the big curved line that the circle is in fact is all equally distant from that center point. So we need now to know the distance from one of these to the other, and that's going to just be another circle. We're going to copy this with a compass, essentially. Now, GeoGebra is dynamic. It helps if you make your circles relatively small. So we're going to do that. We're going to make that circle a little bit smaller. And the smaller you make them, the more it's going to help as we go along, because the triangles are going to get smaller and smaller and smaller. Okay, so having done that, we now choose our compass tool, which enables us to copy a circle. So we're going to copy from here to there. We're going to copy this littler circle here from there. Okay, and now we're going to find the intersection point of those two circles. If we can get close enough. Intersection point. Great. Now we're going to draw a line. 2 points define a line. We're going to make that intersection point. We're not going to keep that whole line. So take that now, and I'm going to hide it. And we're going to make a line segment from there to there. All right. So that's where we are. That's how you copy an angle. And we're going to keep going around. As we copy, what we're doing is we're creating another angle that looks like the entirety of the golden triangle. And then we're cutting off this sort of obtuse isosceles triangle is what's left. So as we go along, we're gonna have a smaller replication of the golden triangle, and we're gonna have another division of the previous golden triangle into a new golden triangle and a very obtuse isosceles triangle. Okay. Now, as we get smaller and smaller, it's going to be harder to take the previous circles that we use to copy our angle. But since GeoGebra is dynamic, as we go along, we can also keep making the original circle that we used to copy our angle smaller and smaller. And as you zoom in, you see that it makes no difference to the size of the triangle. From a craftsmanship perspective, if you're doing this with an actual compass and pencil and ruler, it's not necessary to make your original circles very small, and it's not really even going to help you that much. You just you can just start by making smaller circles on the previous step, and just copy them as you go along. Also, from a craftsmanship perspective, you can't really start with a circle that's really all that small. You want to be able to see your lines and where they intersect, and bigger shapes help to some extent, but on the computer we're in the ideal realm, and we don't really have to worry about some practical considerations. All right. Okay. All right. Now at this point, I'm thinking it might be a good idea to go ahead and stop and clean up some of my circles. So, um, let's see. I guess I'm gonna have to. Some of these I'm gonna want to see if I can do as a group. Because there's a lot of them. Alright, while I'm at this, while I'm zoomed in on these, I'm going to go ahead and minimize some of my dots as well. Okay. So can I do a group over here? Alright, super duper. I think that makes sure. So you can sort of see how it starts to go. Right? Now, the next thing I want to try to do. Oh, we're over 10 minutes. All right. Well, let's try to keep this. Let's try to keep this thing moving here. Let's go ahead and do circular arc. So, in the golden triangle, you can create a sort of a nautilus spiral of Fibonacci spiral. It's not exactly going to be the same as the ones you did. Oh, well, it's not exactly going to be the same. There's a undo up here. Oh no, I did two undos. All right. It's not going to be exactly the same. Oh my goodness. Okay. All right. So the key is when you cut this thing down, that obtuse isosceles triangle that you create, you're going to use that as your basis for drawing your arc. You're going to put your center point at, I guess, the obtuse angle, and then you're going to go around. Yay. You're going to put your center point at the obtuse angle, and you're going to go around like that. Center point at the obtuse angle. See, we're doing the smaller one each time. Center point at the obtuse angle. Center point at the obtuse. Whoops. Well, see, now we got to zoom in. Right, so center point at the obtuse angle. Center point. That's not it. All right, and that's as far as we can go right now because that's all the little triangles that we made. So there you go. The spiral on the golden triangle. Okay, we're at 16 minutes. I just wanted to mention real quick that the golden triangle can be constructed also from the golden rectangle. The sides are the same length. The base of this triangle, as we're looking at it, the short leg, is in fact 1, and the long leg is in fact phi. That is 1.618 in comparison to that 1. You know, phi being an irrational number, which you derive by formulas or by procedures, such as, creating a pentagon. You can also do it by simply sweeping down the sides of a golden rectangle until they meet. That is to say, you create two arcs, which would have as their their base. So that is to say that you sort of fold down the edges until they meet and make an isosceles triangle. So the golden triangle is if the base were the same unit 1 in both cases, the golden triangle would be slightly shorter than the golden rectangle, but its leg would be just as long. Anyway, that's gonna have to be it. Over and out.